Okay. Hi, everyone. I'm here to talk about static analysis options in Python. So this is just an overview of static analysis. It's learning everything you can about your code without actually executing it. Unit tests are generally a lot more useful for making sure that everything works, but sometimes you want something that's easier to get up and running. And the basic question is, why doesn't a bad script just fail to compile? And compilation means that you want to have 0 false positives, whereas with static analysis, we're more interested in what we can learn in general about our code. Oops. Okay, whys. We want to find certain classes of bugs, things that are obvious when you look at code. It's certainly not going to find everything. Good bang for the buck compared to unit tests. You may also be interested in making your code similar. You have different members of your team, and you want them all to have like similar variable names or have similar spacing to try to keep them on the same page. And that's just as useful as finding bugs. Behavior is frequently incorporated in IDEs. I love PyCharm. It's just a great IDE, and I use it for a lot of screenshots here, although the command line tools will have a lot of similar functionality. And static analysis is best used with a build server so that you can run this every time that you make a commit and push it, so that you have instant gratification, instant knowledge of your errors or things that don't quite line up. So regarding code style checking, you can test for the length of variable names or even like camel case or underscores or whatever. You can test the number of lines that functions have. Tabs versus spaces is pretty easy to check for. You can forbid any use of eval, which is generally a code smell in most cases. And pep8 is the official Python standard that has a lot more different rules. So one of the problems here is you have some amount of false positives. This is a Flask application that I'm developing on my laptop, and this transaction account and rule are all models, Flask models, and it uses SQL alchemy, and there's a lot of magic going on under the hood, so Pylint is not quite aware of that. Even though Pylint is aware that I am using SQL alchemy, it's not aware that these functions are created. These members exist. So to get around that, you kind of have to either ignore the warning or filter it somehow. So here are some just screenshots. You can get invalid imports. That's easy to detect. Keywords where they don't belong. Here the problem is that the indentation puts the return in the wrong space. In this case, it's smart enough to tell that there's no possible paint method there. But if you see down at the bottom there, it does know about draw. Too many or few arguments is also easy to detect. Things that can't be caught. So here, there's a typo there in the bottom, args.jxoin. It doesn't have any idea about that because this information it gets from the fourth add argument call there at runtime. It doesn't know anything about like types that are on one side, like on the client side, and if you're using, this is twisted here. It doesn't, it may run, if you have those methods, it doesn't know anything about the types. The same rule applies for callbacks in general, which is a bit of a pain. So different options. Pylint is the most thorough. It does copy and paste detection, code quality detection, Error checking, it's very configurable. You definitely need to configure it to, because the defaults are a bit, usually not really what you want. And it supports Python 3, which is great. Pychecker is another tool that shares the same abstract syntax tree. It's generally nice for checking code, but it's also, I think the last release was in 2011, so it's not really up to date. Pyflakes is nice if you want to have a fast response and only check for things which you know to be like code smells, like if you declare the same method twice. Astroid is the library which Pylint and Pychecker use. I've been hacking around with this a little bit. It's actually pretty intuitive. It adds on some type inference capabilities that the default Python abstract syntax tree doesn't have. So there's some definitely neat capabilities there if anyone else feels like hacking around with it. And then there are other related topics which I'm not going to go into right now. Cython, which is sort of a compiled language like Python. Refactoring tools, complexity analysis, yeah, and function annotations. And that's it.
Any questions?